Class. This will be our last unit from Unit 3. It'll be over Section 4.4, Early Number Systems. I will do like a test review video, but in terms of topics for Test 3, this is the last one. So 4.4, Early Number Systems. This to me sort of goes like 4.1, 4.4 sort of more the history of our number systems, where 4.2 and 4.3 were more computations with other number bases. So this one's going to be a little bit less heavy on the arithmetic, a little bit more almost like decoder rings. You ever play with those as a kid? You know, like here's the symbols and figure out what it is. That's kind of what we'll be doing here. We are dealing with Egyptian number systems, Roman numeral number systems, and a very little bit of Ionic Greek number system. So, and again, the whole purpose of this, hopefully it'll give you a little bit better appreciation for our actual number system, our Hindu-Arabic system that we use today, because it took a lot of effort of a lot of really smart people to get to the efficient system that we have today. Okay. So that's kind of what we're doing here, is just looking at some of the earlier number systems that a couple of civilizations have used. As always, I am pulling the notes that I've got posted in Blackboard. So let's just jump into them. All right. Yeah, some of these number systems are a little bit more friendly than others. The Egyptian number system is probably I think is pretty straightforward. The Roman numeral system is a little bit more complicated. Of course, that's the one we see occasionally, and so we'll spend a little bit more time on that. One thing to remember, just a couple things, is a lot of these number systems didn't have a symbol for zero, which may not sound like much, but if you don't have a symbol for zero, it's kind of hard to talk about it, like a regular number, right? So, and even to this day, in Western civilization, since we treat zero as sort of nothing, that tends to cause problems. Right? But so a lot of early number systems didn't have zero there. And also, if you're wondering about the symbols and stuff they use, remember they didn't always have paper and pen. Sometimes they had stone or clay. The Egyptians, they like their hieroglyphics, so that's kind of what they lean towards. So those digits of 0 through 9, those took a while to develop. All right, well, I don't think we need a lot of other background on this like we did with 4.2 and 4.3, so let's just jump into this and see if we can do some translating. We'll start with the Egyptian number system. And again, you're going to have all these symbols in the homework on every problem, so you don't have to have these memorized. You just have to know how to use them. Okay. So Egyptians, like their hieroglyphics. One is a one. After that, it gets a little funky. And so look at this, and let's see if we can translate it to our number system. All right. That's it. Read it from left to right. So that is one nice thing. We're not reading left to right or anything like that. We're reading in the same direction we normally read. So we're starting with two astonished people, three pointing fingers, two spirals, two heel bones, and three staves. Okay, so what does that mean? Well, astonished people, those are millions, right? So that would be, I don't know how you want to write this out. So a million, see, 6 zeros, 1, 2, 3, 4, 5, 6, plus a million, and then three fingers. Well, you could write out, say fingers are 10,000, so that would be, well, let's do this. So we have 2 millions, so let's be official about this. So that would be 2 million plus three fingers. Well, that's 10,000, so that would be 30,000. So this is basically, doing expanded form, but instead of having powers of 10, we're doing different symbols for powers of 10. So what are we at? The spirals are 100. We have two of those, so that would be 200. Then we have three heel bones, so that would be, two of those would be 20. And then three stabs, so that would be 3. So instead of saying 10 to the first, 10 to the second, 10 to the third, and so on, they just gave them new symbols. Kind of have to do that if you don't have exponential notation. So what is our final answer? 2,030,223. Yes, that's all we're doing here with Egyptians is translating symbols to numbers and vice versa. Uh, which I do think it's interesting uh, to to see how other civilizations think. And it took, just think how long did it take them to get to decide to do different symbols or different powers of 10, but if they didn't have exponents. All right, so how about the next one? We have two fish, or sorry, tadpoles. So that would be 200,000. Three spirals is 300. Heel bone, which is 10, and then three stabs. So it would be 200,313. Yeah, I think you get the idea, right? Like I said, Egyptian number system is, I think, user friendly. It's going from left to right, from highest place value to lowest place value. You have a single symbol for everyone. So, like if you wanted 9 million, they're not going to do anything fancy. They're just going to do 9 astonished persons symbols. And so we'll go from there. All right. So, how about do one of these that's go the other way. So, how do we convert 2034 into symbols? Well, I would start with the highest place value of 2000. So 2000 is a lotus blossom. So we need two of those. Well, right off the bat, looks like it pretty much has to be D, right? Because it starts off with, that's the only one that starts off with two lotus blossoms. Now let's make sure that we have it right. So then we have three heel bones, so that would be 30, and then four stabs, so that would be 2034. So yes, that is definitely. Now sometimes if it's multiple choice, it makes it a little bit easier. Let's try one of these that's not multiple choice. Now, it will be multiple choice in MyMathLab, but just for the fun of it, let's do it without multiple choice. That way we can practice our drawing skills. Okay. All right. So if we want 1,235,042, so a million is an astonished person. We'll throw the hands up in the air. All right, 200,000. So that would be two tadpoles. Okay. You have to excuse my drawing. This is why this is multiple choice. 30,000. So that would be three pointing fingers. Yes, those are fingers. Um, then 5,000 would be five lotus blossoms. I'll let you fill in the rest of it, the actual blossom. Yeah. And then there are no hundreds, so we have no spirals, which kind of, that's actually my favorite symbol is a spiral. I don't know why. 40, so it's four heel bones. 2, 3, 4. Upside down U's, and then two that you should be able to find in the multiple choice. Yeah. So Egyptian number system, again, like this is sort of, 4-2 and 4-3 was a little bit heavier on the arithmetic. This section's not so bad in that because we're just translating back and forth. There. So now if you're ever watching a movie with Egyptian hieroglyphics in the background, now you're going to be wondering if you're seeing numbers instead of letters. Okay. How about the Roman numeral system? This one we still definitely use or see occasionally. I hope we use it. Super Bowls, they count that way. A lot of companies, when you see like their copyright sort of thing, like we was established in whatever year. I don't know why they use Roman numerals. Maybe it looks fancy. Same with publishing. A lot of times in books, you'll see that the copyright year will be written in Roman numerals rather than our normal Hindu-Arabic number system. Again, if maybe people think it looks fancier, so they like the look. But that's typically where we see a Roman numeral system these days. So let's talk. So what do those numbers mean in the Super Bowl? How do they get it? All right, so the Roman numeral system is not quite as you definitely I would say not near as user friendly as the Egyptian one. There is a little bit more work involved in reading it, so let's talk about that. Right, so first, again, we're going to read the symbols from left to right. So when you have these symbols, go left to right. Now, most of the time, we're going to be adding the values. And so again, you're going to be given the table. And if you notice the values that they have values for powers of 10. So 1, 10, 100, 1,000. I'm sure they have numbers for symbols for bigger ones. Actually, they actually have multiplication in Roman numeral system, which just a real quick aside, if you ever see a Roman numeral with a bar over the top, that means multiplication by 1,000. So I think that's how they get bigger numbers is they just take the smaller numbers multiplied by 1,000. Just total aside. I actually there may be a homework problem where it asks you what that symbol is, and so now you know. Right. Now, most of the time when we're, not only does they have powers of 10, but they also have 5 times powers of 10. So 5 times 1, 5 times 10, 5 times 100. And so most of the time, once you translate these, you are going to be adding the values. So we'll be doing, 10 plus 50, if we have 2x, xx would be 10 plus 10. But sometimes we do subtract, and that's where I think the Roman numeral system gets a little messy. So how do you know when you're adding the values versus subtracting? Well, as you go from left to right, if the values are decreasing, then you're adding. So it's a bit backwards, what you might think. So decreasing means add, increasing means subtract. So like here we have x is 10, and then we have 1, 1, 1. So if you notice the values, well, if they stay the same or decrease, right? So these are decreasing from 10 to 1. So these are just added. So that would be 13. Now, if you increase, then you're going to have to subtract. So on the XVI, let's see, that is, do we add or subtract? No. Now on this one, number 10, we have M, which is 1,000. We have I, which is 1, and X, which is 10. So those two right there decrease. That's what I mean. If you decrease from left to right, oh, wait a minute. You're talking about subtracting. Sorry. So those increase. And so if you increase from left to right, you subtract. So we're going to be subtracting 10 minus 1 here. One of the things to keep in mind as you're translating is when you subtract, put those in parentheses. So this would be 1,000 plus 10 minus 1. So all our subtractions are in pairs. Put parentheses around them because those are a single number. So here's a little bit shorter example. I know I had this in here for a reason. So if we have xi, xi means a 10, then a 1 from our chart up here. And so since it goes from 10 to 1, that's decreasing. So we're adding those to get 11. But if you do ix, well, that means you start with 1 and go to a 10. Those are increasing. And so if you're increasing, that's when you subtract. 10 minus 1 gives us 9. Now, a couple other things to point out, and then I'll make the subtraction a little bit quicker, I think. So we can only subtract powers of 10. So you can only subtract 1, 10, 100, and so on. We won't be subtracting 5s, 50s, 100s. Reason there, let's say that you try to write something like Vx. Well, V is 5, X is 10. Now, if you look at that, that's increasing. So we subtract. But 10 minus 5 is still 5. So we don't need Vx because Vx is just V. Okay? So we're only going to use subtraction with powers of 10. Now, the other thing that is going on in the background, and I don't know why this is, For Roman numerals, you can only repeat a symbol 3 times in a row. You cannot repeat it 4 times in a row. What do I mean by that? Well, 1 is I, 2 is I, 3 is 3 I's. But for 4, you cannot do 4 I's because that would be repeating 4 times in a row. And also, if you get above 5, so VII would be 7, the 3 I's would be 8, but you can't do V and 4 I's to get 9 because that would put 4 I's in a row. You're only allowed to use a symbol 3 times in a row before you have to change symbols. And if you notice, it's the 4 and the 9 that we can't get to by repeating symbols. So if we're subtracting, the only time you're going to have to subtract is if a 4 or a 9 is involved, or a 4 or a 40 or a 400, or a 9 or 90 or 900, and so on. So if there is no 4 or 9 in the number, there is no subtraction. It's all addition. So keep that in mind. I think that will make like over here earlier, I said most of the time we will add the values. Like I said, that's if you that make again if you know you're looking for 4 or 9 to subtract, I think that might make it a little bit quicker. Okay, so let's go back and do some translation. So let's finish this one. So we did M, which is 1,000, IX, so that's 1 and 10. And so we're decreasing, so we're fine. But then 1 to 10 increases. So those two get subtracted. And again, I said put your subtractions in parentheses. So that would be 1,000, because we're going to add, like after we subtract it, we're going to add that sum to the other numbers. 1,000 plus 9 is 1,009. Let's back up to that XVII. So X is 10, V is 5, and then 1, 1, 1. Now notice those are all decreasing or staying the same if they repeat. There is no increasing, so we're just going to add all of those. So that would be 18. So XLVI. So X is 10, L is 50, V is 5, and then I is 1. So if you notice, from 10 to 50, that increases. And if we increase in value, we're going to subtract. We're going to do 50 minus 10, put those in parentheses. Now, from there, we're decreasing, so we're going to do plus 5 plus 1. So when you subtract, we're only subtracting a pair at a time. So that would be 40 plus 6 or 46. So if subtraction's involved in base 10, there's going to be either a 4 or a 9 somewhere. So here we subtracted 10 minus 1 to get the 9. Here we subtracted 50 minus 10 to get the 40. If we wanted, say, 400, how would we get 400? Well, we would have to do 500 minus 100. Or if you wanted like 999, well, that would be 1,000 minus 1. So as long as there's a 4 or 9, you have to think in terms of subtraction to get those 4s or 9s. Every other digit, we're just adding. Okay. Well, how about a little bit longer one? So we got MM. So there's 1,000 and 1,000. Then D is 500. C is 100. L is 50. Then X is 10. B is 5. 1, I is 1. If you notice, it stays the same, decreasing, decreasing. So in no point in that number are we increasing as we go from left to right. That means this is all add. And notice I don't put my answer track in until after I get the digits because I want to figure out how to subtract first. So that would be 2,000 plus 600 plus 60 plus 6. Yes, I could have used a calculator, but 60. 50. Okay, so that would be 2, can't write today. So 2,000, maybe I should get to calculator. 2,000 plus 600 plus 60 plus 6. So that would be 2,666. No subtraction needed because we were decreasing or staying the same the entire time from left to right. So what if we go the other way? So like now, let's do 57, 42, 136. I don't have near as many of these in the homework as the other way, so because these are a little bit messier, but so how do we convert a number in Hindu Arabic back to Roman numerals? Well, first of all, what I would look for, and you can do these a little bit out of order, but I want to know if there's any subtraction needed. If there's subtraction needed, then I need to figure out like those pairs that I'm going to have to subtract. And so to me, those will be tied together. You're going to subtract. If you have a 4 or 9 anywhere. Next, I'm going to figure out which symbols we need and do this kind of by place value. So figure out how many thousands you need, how many hundreds you need. If you need the halfway point, do you need 50s or 500s or 5s? So start working on your symbols to build up those numbers. And then once you do that, again, think in terms of powers of 10. Think in terms of place value as you're figuring out your symbols. Start with the biggest place value first. So do you need any thousands? Yes or no? Do you need any 500s? Do you need any hundreds? Kind of work in reverse order, from largest to smallest. Once you do that, then we need to get the order. So a couple things to remember in the order. Decrease from left to right means we're adding. That's why I like to do my subtraction first, because those will be backwards. And always start on the left with the bigger place value, work your way down. Okay. So how about 57? How do we convert that to Roman numerals? Well, first thing I would do is there is no 4, 9, so we don't have to subtract. That makes it kind of nice. And so once we know that, let's split this up in terms of place value. So 50 plus 7. So how do you get 50? Well, 50 is L. And then to get 5 or to get 7, we need, well, we can't use it. So we need 5 plus 2. We need VII. And there's no space between those. So that's kind of how I do it, is going to go by each place value. We didn't need 100. First of all, there was no subtraction. The number was less than 100, so we didn't need anything bigger than L. So then we just kind of work backwards. So how about 42? So there is a 4 now. So that means we are going to have to subtract. So again, think of this as 40 plus 2 and break it down from there. So how are we going to get a 40? Well, 40 is going to be 50 minus 10. And then 2 is going to be I. Well, I mean, that's straightforward. So how do we, excuse me. So to get 50 minus 10, here's where you have to be careful. And so is it XL or is it LX? Remember, if you're increasing from left to right, that means a subtraction. So we need 50. Do we need to increase? So we need 10 and then 50 to get 50 minus 10. So the subtraction symbols have to be backwards. I don't know if Romans wrote their subtraction backwards than we do, if that's the reasoning. But subtraction symbols are backwards. So we need to do XL. So that gives us 10 and 50. So since it's increasing, it's 50 minus 10. So that's our 40. And then II for the 2. So subtraction backwards. Okay. How about 136? So for 136, is subtraction involved? No, because there is no 4, there is no 9. So now let's split this up into place value and get the symbols separately. So for 100, 100 is nice because that's just C. 30 is 3 tens. So we need x, x, x. And then 6, we need 5 plus 1. Now, what order do we put it in? Decreasing means addition. So we want to start with a bigger number, go to the smaller number. So that would be, VI. Because that's 5, then 1. So we're adding. So C, X, 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 DI. And also, if you know that ahead of time you're not subtracting, then you're not putting the symbols backwards. So remember, when we're doing the symbols, we're going backwards to add them. All right, let's do one more. So 2,139, there is a 9 involved. So that means subtract. So how do we get 2,000? Well, so 2,000, we need 100, we need a 30, and we need a 9. So how do we get to 2,000? Well, 2,000, M is 1,000, so we need 2 of those. So that would be MM. 100 is a C, so we only need 1 of those. 30 is 3 tens, so X, X, X. Now 9 is, to get 9, we need 10 minus 1. So we need the 1 first, the 10 second. Remember, increasing means subtraction. Now, what order do we put it in? We start with the bigger ones on the left and work our way to the right. So M, M, C, X, 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 and then I, X to get the 9. All right. Like I said, I know we're not used to using that as much, but we still see it occasionally. And so hopefully now, what Super Bowl is coming up. Let me check something real quick. Okay, so I looked it up, and Super Bowl next year in 2026 is LX. So what does LX mean? Well, L is 50, X is 10. So is that 40 or is that 60? Well, those are decreasing. So since they're decreasing, we add. So our upcoming Super Bowl is Super Bowl 60. There you go. So now you can't say, where are we going to use this in real life? All right. So that's the one we still see. I want to throw one more at you just real quick, because again, I kind of like doing little puzzles, and to me, this is puzzles. And so we have something called the Ionic Greek number system. And so they use their Greek symbols for different numbers. All right. And so you had they had a lot more symbols because they had symbols for 1 through 10. Then when you start multiplying those by 10, then they just had symbols. Now this gets cut off. There was other symbols for the hundreds, the thousands, so on. I do want to point out that the table for these couple of problems in MyMathLab is much better than this little table. And I'll show you an example of that after we do these two. But it's really the table in MyMathLab, you can just find the right row and the right column to get the number. It's easier. Okay, but let's do a couple of basic problems off this table, and then we'll look at MyMathLab. All right, so we need to write this in our number system. So how do we do that? Well, that's a pi. So you look for pi. There is pi, so that would be 80, and then plus, and again, we read this from left to right. I have to admit I'm a little out of date on being able to read my Greek, but that symbol is right there. Alpha, beta, gamma, delta. Is that delta? I believe that's delta. But anyway, that's a 4. So pi delta, if I got that correct, is 84. Or we can go the other way. We need 125. We need that in Greek form. So again, split it up in in multiples of 10, basically. And so this needs to be 100 plus 20 plus 5. And again, work left to right. So what is 100? 100 is that lowercase q. Then 20 is, what's that, kappa? And then what is 5? 5 is epsilon, lowercase. So 125 in our number system is whatever the Q is, and then I believe that's kappa, epsilon, both lowercase. So rather than just have to know the digits from 0 through 9 and then know their place values as you go to the left, if you were using doing math back when they had that, you had to know a lot more symbols. And it could have, I don't know about you, but like for 2 is beta, 20 is kappa. It's like, how are those related? Whereas for us, we know that 2 is and 20 is 2 times 10. So like, who knows how they come up with this? But just be thankful, unless you really like this sort of stuff, that somebody else came up with this for us. We just have to use it. Let me show you what this looks like in MyMathLab. Like I said, it's much better than what I've got for my program for the homework problem. Okay. All right. And the other thing to remember, you do have to scroll down a lot. So remember, you can like pick chapters. So we're in chapter 4. And so that greatly reduces it. Like next time you open MyMathLab, it'll be back to where it started. So if you forget that you use that, but so we're in 4.4. So the first few problems are going to be your Egyptian number system. So type in an integer. So you get to translate. And then you don't have to draw your Egyptian symbols. Make sure I'm screening. Yeah, so I'm still sharing the right one. Okay. So it will be multiple choice. Then you get into your Roman numerals. And again, your Roman numerals, notice that they give you the chart. So you don't have to memorize those numbers. Yeah. So here they're like, this is like one of the earlier ones. They're asking you if you have I and then X, are you adding or subtracting? Okay, we're not dividing or multiplying, so that should never be the case. And so IX starts at 1, goes to 10. That's increasing. Remember, Roman numeral stuff is kind of backwards. So if it's increasing, it means you actually subtract. So that would be 10 minus 1 to get you. And if the number increase from left to right, you subtract the value. That's sort of a definition sort of thing, right? But then you get into the actual translations. And so it'll start with Roman numerals. You have to get it into our number system. Start small and work big. And then there will be some where you start in our number system and then have to go back to Roman numeral. And so we went through that, but like here, when I see that 9, that knows I have to subtract to get the 9. How do I get 9? 10 minus 1. And everything else is 2s, not 4s or 9s. So then we'd be adding. All right. Here is the Ionic Greek system as MyMathLab uses it. So like I said, I think this is a much easier chart to use. And so it goes a little bit quicker. So write the value of 6,432 using this system. So again, go by place value. So we need a 6,000. So we need 1,000. So you get in the thousands row, and we need 6. So that would be 6,000 would be G. Now we need a 400. So we go to the hundreds row, and we need a 4. So that would be capital V. So lowercase, uppercase definitely matters. And so notice here where they're not using Greek symbols. I think that way, this is a modernization of the Greek iconic system. Just make it easier for us in modern times to be able to use. That way you don't have to know Greek to be able to translate it. So the 30 is in the tens. So we need three tens. So that would be capital L. And then the 2 is in the ones. So that would be capital B. Now notice they are multiple choice, which again, I'm always a fan of multiple choice because that 6,000, we go to the thousands row, that is lowercase g. Well, there's only one that's lowercase g in the front. Now, don't use lowercase g second because remember, we are still reading from left to right. Okay. And then if we go the other way, then it's, again, it's just kind of reading off the chart. So little p, where's little p? The little p is in the 10,000s row. It's in the sixth column. So that is 6 10,000. So that little p would be 60,000. The little I is going to be in the thousands row. It's under the 8. So that would be 68,000. And then you just keep translating. There's only a couple of those. It's not as much fun without the original Greek, but I just kind of again wanted to give you an idea of like how complicated other number systems have been, and maybe you'll do a little bit of appreciation of our base 10 number system. It took a lot of smart men and women over thousands of years to develop the system we have today. So, all right, that is 4.4. And so that concludes all the notes for test 4. So next time I see you, I'll be doing a review video for the test. Till then, have a good day.